Here we go, day 2 of 4 of the geometry review. First thing, we have a triangle. Have to find Z. Rule we're going to use here to find this triangle is very simple. Sum of the angles inside a triangle equals 180 degrees. So there's your triangle. It equals 180 degrees. So Z plus 18 plus 145 adds up to 180. 18 plus 145 is 153. Z plus 153 is 180. Subtract 153 from both sides, and Z is 27. All right, next one. How are we going to find X, Y, and Z? Well, watch this. What do we know about Y? Y and 45. That's a what? Straight line. These two lines are on both sides of a straight line with one line concluding. So these two things are a linear pair. Linear pairs are supplementary angles that are adjacent. So add up to 180. Y plus 145 is 180, so this angle is 35. So you got 35 here. Now we can use this triangle. Forget about this guy right here. You got 35, you got 55, and you got X, form the last triangle. Add them all together. X plus 90 equals 180, and X equals 90 degrees. All right, so you play a little game there to find all the angles. Next one. Why is triangle ABD congruent to triangle CBD? Now what they're giving you here is they're telling you that AD is congruent to AC. Now let me slide back here to give you some rules. Triangle congruence, postulates, and theorems. This is something we did in class, so hopefully you guys remember this. First off, if all three sides of both triangles are congruent, it is SSS, or side, side, side. If you have two sides and the angle is included or between the two sides, it's side, angle, side, SAS. If you have two sides are congruent, one is a hypotenuse, the side across from the right angle, and one is either leg, and it is a right triangle, has to be a right triangle, it is congruent by HL, or hypotenuse leg. If you have two angles and a side between or included between those two angles is congruent, it is angle, side, angle, ASA. If you have two angles that are congruent and the side is not between the two angles, but that is congruent, either side, so this has to be this side, this could be either one, that is angle, angle, side. That's the non-included angle. So what do you think problem 28 is? If you said AD is congruent to DC, so let's make those two guys congruent. All right. We know that BD is congruent to BD because it is the same side. It's the same for both triangles. We're dealing with these two triangles. And we also have these two angles down here, which are congruent. Now, right angle, check HL. These are the hypotenuses. They're not shown to be equal. So we can't use HL. Now, what do we have here, though? We have a side. We have an angle and a side. Bam! Side, angle, side. All right? A little confusing. We spent a little bit of time on that, though, so it shouldn't be that bad for you. What is the measure of each base angle if the isosceles triangle, if the vertex measures 40 and the two congruent sides measure 25 units? So right away, we don't care what the sides measure. We just care about the angle. Now, if it is an isosceles triangle, that means what? Two angles are equal. Two sides are equal. Two angles are equal. The vertex is 40. The vertex is the side that is not equal. So here's your vertex is 40. It's isosceles, so these two angles both have to be X and X, right? The two congruent angles are across from the congruent legs. All right, so we're going to just call them both X's. So what is the triangle sum? Triangle sum is 180. X plus 40 is 180. X and X is a 2X plus 40 is 180. Subtract 40 from both sides. 2X is 140. Divide by 2, and X is 70 degrees. Still with me? Awesome. For the next problem. What is Y right here? Well, you have a straight line, and you have a line that comes up. So Y and 118 are, yep, you said it, a blank blank, a linear pair. So they are supplementary. 180 minus 118 is 62 degrees. Now, these two symbols here, congruent symbols, means they are equal. So if we're trying to find Z, the sides across from these are the sides that are congruent in the angle. So Z is congruent to the angle across from here, which is Y. So Z is congruent to Y. Y is 62, so Z is 62. So now we got 62 here. And we got another 62. And now we're trying to find out what X is. So Sum of a triangle, 62, 62, and x all add up to 180. 124 plus x is 180, and x is 56. So we started with this, made into this to find that. All right? Not too difficult, is it? It's easy. All right, let's look at the number 33. Yeah, this is triangle C, D, E is congruent to triangle what? You have to make sure the letters are in the correct order. So, side, side, side theorem. Side, side, side. So C, D. So from C to D, you go through the two hashes. So we know that AC is congruent to there, GB, D3. Okay, so all three of those things are congruent based on these symbols. So we start at C. We go from C to D. So here we go C to B. So those two angles are congruent because they're both between the double and the triple. Double and the triple. And then finally, we go to, through the triple, between the double, the single and the triple, between the single and the triple is A and E. So that's your answer, CBA. Right? And then this just means these two angles are congruent, these two angles are congruent, these two angles are congruent. So we're just using congruence theorems. Got it? What is this figure doing to get from shaded to unshaded? What do you think it's doing? Is it translating? Is it sliding? No, because the figure looks different. Is it reflecting? Is this an actual reflection over one of the axes? No. Is it a rotation? Yeah. It's actually a rotation of 270 degrees clockwise or 90 degrees counterclockwise. All right, you're just taking this figure, rotating it around. 90, this triangle would be facing down. This triangle would be facing to the left, and then it goes up, and then it goes right back to the same position. Little translations for you. Not translations, transformations. All right, let's do some reflections. If this point right here is reflected over the x-axis, what is its new point? I always like to put a little chart down just to help myself. Now, I'm reflecting it over the x-axis. This is the x-axis. When I do that, when you reflect something over the x-axis, you're going to multiply the y-coordinate by -1. Now, in case you forget how to do that, I really don't like memorizing formulas. I go, okay, I'm going to reflect it over here. So when I do that, I'm going to stay at -4, but instead of being 9 units up, I'm 9 units down. So my answer, which is x negative y, becomes -4 still. Now it's -9. What happens if I reflect it over the y-axis? I go from being -4 to +4, and I'm still 9 units up. So you change the value of the x. Say you're a formula memorizer. You like to do that? Just remember these formulas. So your answer is 4, 9. I'm more of a picture person. Say I want to reflect it over both. Well, you can reflect it either way, but you're actually just going to change both the signs. It's going to go from a negative and a positive to a positive and a negative. So you reflect it over here, you get your 4, 9. All right, to come down here, I keep my 4, but my 9 goes from positive to negative. If I went this way, went to the -9, keep the -9, -4 goes to positive. Got it? Hopefully this graph helps you. All right. Next couple problems. Identify the coordinate point 12, -2 after a clockwise rotation. You can use notes, so I'd have these notes down there. If you rotate something 90 degrees, you switch the x and the y, and whatever the x is, you make negative. So for instance, 90 degrees, now this is just clockwise. Counterclockwise is just, you switch the 90 and 270. So say you start here with 5, 4. If you want to rotate 90, you switch the 5 and the 4, and this becomes negative. So it's 4, -5. Say you want to move 180. You just take these two units, and you make them both negative. -5, -4. Say you want to go 270. You flip these, 5 and 4, right? And what you do is, you make this negative. I also use these sometimes. I just look at my coordinates. I know these are both positive, positive, negative, 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 positive. And I go, you know what? I know that 90 and 270, I flip these, and then I just count. Well, I count down 1 here. The y has to be negative when I get it. I count 2 here. Oh, these both have to be negative. Up 270. Up, my first thing has to be negative. Up to you how you want to do it. Remember, we spent lots of time on this. Just quick review. So 90 degrees. Flip them, right? So you start at 12 over -2. So you're starting here. So when you go 90, you end up in here. Both things are negative. Negative 2, negative 12. 180, all right? They both become opposite signs. Negative 12, positive 2. 270, you're going to flip it, and your b is going to be negative. So it's 2, negative 12. And 360, you remain the same. Got it? 42, solve x. Given BD is this, and AE is this. What rule do you use for this? Anyone? Anyone? The mid-segment theorem. This is half of this. So BD is half of AE. 7, so that also means that AE is 2 times BD. You can do it either way. So 6x plus 11 equals 2 times 7 halves x minus that. 7 over, now you distribute the 2 in. 7 over 2 times 2 is 14 divided by 2 is 7. So this is 7x minus 16. It should be right. All right. Subtract 6x from both sides, or 7x, doesn't really matter. Add 16 to both sides, x equals 27. Good? That's it. Given AE bisects DAB, these two angles are equal. So now it's an angle bisector. CD is 12. CE is 5. Right? What is, what are we looking for? EB. So what we know is because this is an angle bisector, these two segments are equal. Because these are both right angles, the distance to the same point on the bisector is going to be equidistant. So if we find ED, we find EB. Now we know the Pythagorean Theorem. This is 5, this is 12, so you can find this. You can use a triple if you remember it. 5, 12, 13. See, told you they'd come in handy, but most people don't like triples. If you don't, you can go old school. 5 squared plus 12 squared equals x squared. 25 plus 144 is x squared. 169 is x squared. Square root of 169 is 13. See? All right, so this is 13. I told you before these are equal, so this is also 13, which is what we're looking for. And that's it. That is an angle bisector theorem. 44. Which ones of these side lengths allow you to construct a triangle? Now, the rule for a triangle is if A plus B, the two shorter sides have to be larger than the largest side. Okay, they can't be equal. So either that's true or it's not a triangle. So let's look here. What about 3, 4, and 10? So the actual theorem here, here's the theorem. The sum of the lengths of any two sides of a triangle is greater than the length of the third side. So you could do any two sides has to be bigger than the third side, but if the two smaller sides are bigger than the largest side, the largest and one of the smallest is obviously going to be bigger than the other ones. All right? Can't be equal to. So small side plus middle side has to be bigger than the longest side. Got it? We did this in chapter 5, obviously. So 3 plus 4 is 7. Is 7 greater than 10? No, not a triangle. 10 plus 10 is 20. Is 20 greater than 10? Yes, it is a triangle. It's actually a equilateral, equiangular triangle. Here, you don't just add the first two numbers, you add the two smallest numbers. 5 plus 4 is 9. Is 9 greater than 11? No, it is not. 8. 5 plus 3 is 8. Is 8 greater than 8? It's equal to. Equal to is not the same as greater than. Not a triangle. Your answer is B. Now here's three other problems that I threw on for you. All right, just to make sure that you got this. Got it? All right, so do these three. 3 plus 4 is 7. Is 7 greater than 5? Boom, triangle. 6, 10, 8. 6 plus 10 is 14. Is 14 greater than 10? Of course it is. And 1 plus 1 is 2. Is 2 greater than 3? It is not. So that's not a triangle. All right, we good? All right, problem 45. Which side lengths allow you to construct a right triangle? Remember the formula for a right triangle? Pythagorean Theorem. When you have a right triangle, c squared equals a squared plus b squared. Then this angle is 90 degrees, so this is indeed a right triangle. So if you square the two smaller numbers and it equals the hypotenuse, the largest side, it is a right triangle. So 3 squared plus 4 squared. 9 plus 16 is 25. Is 25 equal to 49? Not a right triangle. All right. This would actually be a obtuse triangle. All right, next one. 5 squared, 12 squared, 169. They're equal, so B is a right triangle. 9 squared is 81. Is not equal to 162. Okay, not a right triangle. This is actually a acute triangle, or otherwise known as a equiangular triangle. All the angles are 60 because all the sides are the same. 714. 245 is not equal to 400. Not a right triangle, actually not a obtuse triangle. Oh, leave there for a second. And let's get through the last slide here. Ready for Pythagorean Theorem? 25.5-foot ladder. There's my ladder. Rest against the side of a house, like the pretty little house I drew, at a point that is 24.1 feet above the ground. The foot of the ladder is x feet away from the house. Find the value of x to the nearest 10. What do you use here? Houses make right angles. Hopefully your house is falling down. A right angle Pythagorean theorem. Now, which one is my C? That's the right angle. Across from the right angle, 25.5 is my C. X squared plus 24.1 squared equals 25.5. Square everything, subtract, and take the square root, and you get 8.3 feet away. So this is 8.3. Awesome. Any questions? No? Last one of the day. Word problem. Lyndon, that's where you live, wants to construct a new street that connects Linden Avenue and Tiger Place. The construction is estimated at 85 feet per linear foot. Find the estimated cost of constructing Paul Street. Ooh. There you go. What do you have to do find first? First thing you have to do is find how far Paul Street is. You know it's 12 feet on Linden Avenue, 12 miles, and you know it's 16 miles on Tiger Place. So how do we find this? Pythagorean Theorem, 16 squared plus 12 squared equals whatever the length of Paul Street is squared. All right, you get Paul Street is the square root of 400 or 20 miles. So 12 squared plus 16 squared, square root of that is 20, so Paul Street's 20 miles. So 85 feet per foot. If it's 20 miles, you convert miles to feet. How many miles is in a foot? 5,280. So 20 times 5,280 equals 105,600 feet. That's how long this road is. Now, how do we convert this to see how much money it costs? If it's $85 per feet, we take this number and multiply by 85. 105,600 times 85 feet gives you 8. Whoa, I forgot a zero there. Uh-oh. That is 8,976,000. I don't know where my zero went. Here, I'll put in there, 0. All right. So that is your answers. And that concludes, let me slide in here. So that concludes our review for today. You guys did excellent on the Kuda Hoop before, hopefully. Looking back at this, any mistakes you made, you can see it, you can fix it up. Once again, if you have any questions, feel free to email me. And that's it. Till next final review. We're halfway there. 2 more classes left.